Welcome back to the Functional Python series. In this video, I want to talk about anonymous functions, typically called lambdas. Anonymous functions are expressions that when evaluated, they return functions. And they are a very important concept in functional programming. As usual, the code for this video is in GitHub. The link is in the description. And I also want to know what you think about the dark background instead of the white background. So please add a comment and then let me know what you prefer. Okay, so let's get started. So functions are first-class citizens in Python. That means that they should behave like any other value. It means that it should be possible to create an expression, then evaluate it, returns a function, an anonymous function. So for example, if we have this code, we have a function that returns the sum of two values. We can rewrite this function as a lambda expression and then assign this to a variable, in this case g. And then we can call g like any other function. So if we run this code, the output will be 5 and 5. So essentially g and f do exactly the same and behave the same. So it is an expression. A lambda expression is an expression. And when evaluated, it returns a function. We do not need to assign it to a variable. We can call it directly. In that case, we refer to it as an anonymous function because we're using the function without a name. We will see that there are other uses for anonymous functions towards the end. So for example, here we can call f with the parameter 2 and 3, or we can create a lambda expression that when evaluated, returns a function that adds two values, and then pass the parameters as we do in the right-hand side. We can also verify the type of the expression. So in here, you can actually see that if we run this code, we will see that the type of f is a function, but the type of the lambda expression is also a function, okay? Now, what about the syntax? Well, the body of a lambda function is only one expression. And unfortunately, due to the syntax of Python, that reduces a lot the power of lambda expressions. For example, in lambda expressions, you cannot create variables because you cannot create variables inside an expression. And so that means that they're only useful for very simple functions. And perhaps that's actually a good thing. Why? Because giving a function a name improves readability significantly. Here's an example of a function. So if you look at it, it's very, very difficult to know what it does. When I run it, it actually outputs the number 11. And because what this function does is adds 1 to its parameter. It's not obvious. Of course, this is a very contrived example, but that gives you an example of functions that is very, very difficult to know what they do. It would be much better to create a function, even if it's very small, that we call it add1, and then call this function. In this case, I don't need to understand how the function works. In my brain, I already have a name for its functionality. So that's actually why I think that it's a good thing that we cannot have complex functions in lambda expressions. There are further limitations. They can only be written in one line. That's really a consequence of the fact that they are just one expression. But you can also use backslash if you need more than one line. And also, because they don't have a name, we cannot have a recursive lambda expression. Because what name do we use to call it? For example, let's look at this code. So in this case, I have an if-else expression. So return 1 if I is equal to 0, otherwise return 20. I'm breaking it in two lines to try to demonstrate how to use the backslash. And notice that in the body of the function, which is from the 1 to the 20, we cannot call f. Why? Because f exists only after the expression on the right-hand side of the equal sign gets assigned. It does not exist before. So therefore, if I try to call f within the lambda, I will actually get an error because f is not actually defined. And if I run this function, it just does what I expect, which is just to print 20. So why do we need lambda expressions? So many functions take a function as a parameter. And it's very, very frequent that we need to pass as a parameter a very trivial function. So that's why in many cases we create a lambda expression. Here's an example. I haven't talked about map. I will dedicate an entire video to it. Map takes as a parameter a function and an iterable, actually, for example, a string, and then applies the function to each element of the iterable and returns a string with the result. So let's look at an example. So in this case, I have this list 1, 3, 5, 9, and my lambda adds 1 to this value. And then I convert the string into a list and I print it. This is exactly the same as doing this, passing add 1 instead, and then calling map. So for very, very trivial functions, like in this case, adding 1, then there's no need to create a function for that. That's the typical way that we use them. So if we run this function, we will actually see that the output if we run this code, we will see that the output is the same. So in conclusion, lambda expressions are expressions that return a function, and they're meant to be used for very simple functionality. Otherwise, then create a function using def. It increases readability and maintainability of your code. And that's basically all for this video. And I'll see you in the next.